Okay, so today we're diving deep, and I mean literally deep, into one of the biggest mysteries right here on our own planet. What is actually inside the Earth?
You know, we love to explore, but there are some serious limits. Think about this. The deepest hole we've ever managed to drill only scratches the surface. We're talking about 12 kilometers down. But the center of the Earth? That's over 6,300 kilometers away. So how in the world do we know what's down there?
Yeah, that challenge is exactly what sets the stage for our first section. It really is a planet-sized mystery.
I mean, the heat and pressure down there are just unbelievable. Sending a probe or trying to drill to the core, forget it. It's completely impossible. So scientists had to get clever. They had to become detectives, right? Looking for clues that were hidden inside the planet itself.
So what kind of clues are we talking about?
Well, that's exactly what we're going to get into in Section 2. Echoes from the deep.
The answer, and this is pretty brilliant, comes from earthquakes. Yeah, seriously. When an earthquake happens, it sends these incredibly powerful seismic waves vibrating through the entire planet. It's kind of like striking a giant bell. And these waves, they're basically our messengers from the deep.
Now, these messenger waves come in two main types. First, you've got your P waves, or primary waves. They're fast, and they can travel through both solids and liquids. But then, you have the S waves, or secondary waves. And here is the absolute crucial difference. You gotta remember this. S waves can only travel through solids. Only solids. That one tiny detail, it's the key that unlocks this whole mystery. And understanding that one key difference, well, that leads us straight to the big breakthrough moment. Which brings us to Section 3, Decoding the Shadows. So you have scientists setting up these seismographs all over the world, listening for these earthquake waves, and they start noticing something, well, something strange. For any given earthquake, there were these specific areas on the other side of the planet where the seismic waves just vanished. They didn't show up. They called these spots shadow zones. See, it turns out the waves don't just zip through in a straight line. They actually bend and curve as they move through different materials inside the planet. And some apparently get completely blocked, creating these shadows where the seismographs pick up nothing. So the big question was obvious. What was blocking them? And this is where it gets good. The disappearance of those S waves, that was the smoking gun. Remember what we said? S waves can't travel through liquid. So when they vanished, well, the scientists realized there had to be something absolutely massive and liquid deep inside the Earth that was just stopping them dead in their track. The original research basically said it all. It went something like, S waves are not recorded beyond 103 degrees, which indicates that the outer core of the Earth is in a molten state. I mean, can you imagine that moment? That was the aha. The only thing that could explain this giant shadow zone where S waves disappeared was a huge liquid outer core. But wait, there's more. The P waves helped fill in the rest of the picture. See, even though they could pass through that liquid core, scientists saw that they bent and slowed down in a very specific way. And by analyzing that change in speed, they could figure out there was something else at the very, very center, a solid inner core squeezed into existence by all that immense pressure.
So when you put all of these amazing clues together, scientists could finally, for the first time, map out the complete anatomy of our planet. Which brings us to Section 4. So by piecing together all of these echoes and all of these shadows from literally thousands of earthquakes over the years, this incredible complete picture started to emerge, and every single clue pointed to this.
A beautifully complex, multi-layered planet. This right here is our current model of the Earth's interior, and the amazing part is we figured it all out without ever leaving the surface. You've got the thin crust we live on, the huge mantle underneath that, then the liquid outer core, and finally, that solid inner core right at the heart of it all. Let's just quickly break it down by the numbers because they're pretty mind-blowing. We start with the solid crust, right? That goes down maybe 70 kilometers. Under that, you hit the massive, solid mantle, which stretches all the way to 2,900 kilometers deep. Then we get to that liquid outer core we figured out, which goes down to 5,100 kilometers. And right at the very center, the immense pressure forges that solid inner core.
You know, a really simple way to picture all this is to just think of a hard-boiled egg. Seriously. You've got the thin, brittle shell, that's our crust. Then you've got the thick egg white, that's the mantle. And of course, the dense yolk right in the middle, that's the core. It's a surprisingly perfect analogy, isn't it?
Okay, so this is all really cool, but why does it matter?
What's the big deal? Well, that brings us to our final section, our planet's engine.
Because this layered structure, it's not just some static diagram in a textbook. Oh no, it is a powerful, dynamic system that is constantly in motion and has literally shaped the world we live on. You've got heat from the core creating these massive, swirling currents in the mantle, and that liquid outer core is just constantly churning away.
So here's the big takeaway, right? This internal engine, it drives pretty much everything we experience up here on the surface. The crust and the upper part of the mantle, they make up the tectonic plates we're all living on. And their movement, which is driven by all that heat from below, is what causes earthquakes, volcanoes, even the creation of entire mountain ranges. And get this, even our planet's magnetic field, the very thing that protects us from solar radiation, is generated by that churning liquid outer core. Our world is truly shaped from the inside out.
So, just by listening to the echoes from its heart, we managed to solve the incredible mystery of our planet's anatomy. It really makes you wonder, though, our planet's hidden interior created the entire world as we know it. What other secrets does that incredible engine still hold?